Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 14, Waves, the last chapter in 11th standard. And this session is not problem solving session, problem questionnaire session. That is, 7 questions will be showered in this session, and in next session we will solve the solution for this question. Let's move to question number 1. Two waves are represented by the equations y1 equal to a sin omega t plus kx plus 0.57 meter and y2 equal to a cos omega t plus kx meter. Here x is in meter and t is in second. The phase difference between them is dash. A option 1.25 radian. B option 1.57 radian. C option 0.57 radian. D option 1 radian. Here we should know the formula for phase difference. What is phase difference? Symbol of phase difference. And in this equation y1 and y2, which is phase difference, which is a phase phi, like that you should know. By knowing the idea, you are able to derive the solution for this question. Let's move to question number 2. Sound waves travel at 350 meter per second through a warm air and at 3500 meter per second through brass. The wavelength of a 700 Hertz acoustic wave as it enters brass from warm air is dash. A increases by a factor 20. B increases by a factor 10. C decreases by a factor 20. C decreases by a factor 10. Here you should know the relationship between wavelength and then velocity of the sound waves. By knowing the relationship, you are able to solve this question solution. Let's move to question number 3. A transverse wave propagating along x-axis is represented by y of x comma t equal to sine 0.5 pi x minus 4 pi t minus pi by 4. Here x is in meter and t is in second. The speed of the wave is dash. Option A 4 pi meter per second. B option 0.5 meter per second. C option pi by 4 meter per second. D option 8 meter per second. Here speed of the wave from this equation of motion, equation y of x comma t, from that you should know the relationship of the speed, velocity v or speed. By knowing the formula, you will derive the solution for this question. Let's move to question number 4. A point source emits sound equally in all directions in a non-absorbing medium. 2 points P and Q are at a distance of 2 meter and 3 meter from the source. The ratio of the intensity of the waves at P and Q is dash. Option A 9:4. B option 2:3. C option 3:2. D option 4:9. By knowing the formula for intensity with respect to the distance, you are able to find the solution for this question. Let's move to question number 5. The equation of a sound wave is given as y equal to 0.005 sine 62.4x plus 316t. The wavelength of the wave is dash. A option A 0.4 unit. B option 0.3 unit. C option 0.2 unit. D option 0.1 unit. So using this equation, you should know the relationship of the wavelength. By knowing the wavelength, you are able to find the solution for this 5th question. Let's move to 6th question. A hospital uses an ultrasonic scanner to locate tumors in a tissue. The operating frequency of the scanner is 4.2 MHz. What is that? Megahertz. The speed of sound in a tissue is 1.7 kilometer per second. The wavelength of sound in tissue is close to dash. A option 4 into 10 power minus 4 meter. B option 8 into 10 power minus 4 meter. C option 4 into 10 power minus 3 meter. D option 8 into 10 power minus 3 meter. So here you should know the wavelength with respect to frequency and velocity. By knowing the relationship between frequency, wavelength and velocity, you can solve this question. Let's move to last question, 7th question. An air column closed at one end and open at the other resonates with a tuning fork when the smallest length of the column is 50 centimeter. The next larger length of the column resonating with same tuning fork is dash. A option 100 centimeter. B option 150 centimeter. C option 200 centimeter. D option 66.7 centimeter. Here you should know the relationship between the length, frequency for closed organ pipe and open organ pipe. By knowing the formula, you are able to solve this question. Okay. Thank you, students. In next session, we will solve the solution for this question. Before that, you solve it and be ready for join to this session. Thank you.